Hello, welcome back once again. Today we have this interesting equation. This equation is a transcendental equation, and we're going to solve for the value of x that will satisfy this equation. We have 8 to the power of x plus x is equal to 11. So let's get started. From the given equation, we have 8 to the power of x plus x. This is equal to 11. Now, in our next step, let us subtract x from both sides. So here we have 8 to the power of x plus x minus x. So this will be equal to 11 minus x, right? Okay, so we can see that from here, x minus x is 0, right? So from the left hand side, we have only 8 to the power of x. So this is equal to 11 minus x. Now, in our next step, let us make the right hand side the left hand side and the left hand side the right hand side. So this equation can also be rewritten as 11 minus x is equal to 8 to the power of x. In our next step, let us divide both sides by 8 to the power of x. So divide here by 8 to the power of x and divide this side by 8 to the power of x. So we can see from the right hand side, 8 to the power of x divided by 8 to the power of x is 1. And from the left hand side, we have 11 minus x in brackets, then 1 over 8 to the power of x. We can write it. Let us first recall this rule. We know that 1 over a to the power of n is equal to a to the power of negative n. So here we have 1 over 8 to the power of x. So this is equal to 1 from the right hand side. Then we can write as 11 minus x times 8 to the power of negative x. So this is equal to 1. Now, in our next step, we're going to make the power of this 8 equal with the expression in the bracket. Remember, we have 8 to the power of negative x. So we need to multiply something, let's call it a number, to both sides of this equation. But the number must have a base 8, right? So we multiply a number to both sides so that when we add the powers of 8, we get the expression in the bracket. Just take note of this. 8 to the power of m multiplied by 8 to the power of n. We can see we have the same base. This is equal to 8 to the power of m plus n. So now, the number we're going to multiply to both sides, the base must be 8, but the power must be this 11 right over here. So you will see we're going to multiply both sides by 8 to the power of 11. So here we have 11 minus x, then times 8 to the power of negative x, then multiply by 8 to the power of 11. This will be equal to 1 multiplied by 8 to the power of 11. Now, with this property here, we're going to add these powers of 8 here. So we get 11 minus x, then times x times 8 to the power of negative x plus 11, right? So this will be equal to 8 to the power of 11. Now, negative x plus 11, we can actually rewrite it as follows. We have 11 minus x times 8 to the power of 11 minus x. So we can see that the power of 8 is equal to the expression in the bracket. So this will be equal to 8 to the power of 11. Now, in our next step, let us take note of the following important property. We know that a is equal to e to the power of ln of a, because the natural logarithm has a base e, right? So when a has a power, so we can write, a to the power of b, we can write it as e to the power of the power b multiplied by the ln of the base a. So we're going to use this property at this place where 8 has a power of 11 minus x. So in the bracket, remember we have 11 minus x, then 8 to the power of 11 minus x, so we can write it e to the power of, in bracket, 11 minus x multiplied by the natural log of the base 8. Therefore, we have from the right hand side that this is equal to 11. Now we're going to make use of the Lambert W function, right? Remember the property of the Lambert W function. So we have the following property for the Lambert W function, that the Lambert W function of x times e to the power of x simplifies to x. The expression at the power of e must be equal with the expression at the side of e. That is, the power of e, which is x, must be equal with the coefficient of e. You can see it here. Now we can see that here the power of e here and the coefficient, they are not yet equal. The only slight difference here is the natural log of 8. So which tells us that we're going to multiply both sides of this equation by the natural logarithm of 8. So by so doing, we get 11 minus x times the natural log of 8, then multiply by e to the power of 11 minus x times the natural log of 8. From the right hand side, this will be equal to 8 to the power of 11 times the natural log of 8. Okay, now we can use the Lambert W function on both sides, right? Okay, so we're going to apply the Lambert W function on both sides of this equation. So from the left hand side, we have the w of 11 minus x times the natural log of 8 times e to the power of 11 minus x times the natural log of 8. So this will be equal to, from the right hand side, the w of 8 to the power of 11 times the natural log of 8, right? Okay, now with the property of the natural logarithm, I mean the property of the Lambert W function, so this place we simplify to just 11 minus x times the natural log of 8. So this will be equal to the w of 8 to the power of 11 times the natural log of 8. Now in our next step, let us divide both sides by the natural log of 8. Divide both sides by the natural log of 8. So we can see this will cancel this, and we are left with 11 minus x, which is equal to the w of 8 to the power of 11 times the natural log of 8, all divided by the natural log of 8. Now from here, I think we almost have the value for x, right? So to solve for x here, we're going to subtract the right hand side from 11. So we get here that x is equal to 11 minus the Lambert W function of 8 to the power of 11 times the natural log of 8, then divided by the natural log of 8. And with the help of my calculator, this is approximately equal to 1.102 361 452 43, and this is the correct answer. Please, if today is the first time of visiting this channel, please do me a favor, subscribe to my channel. If you find this video interesting, please do not forget to subscribe. You can like, comment, and you can share this video with your friends. Thank you.